Okay, 4-4, make sure you write down the section title here, triangle congruence, side, 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 and side, angle, side. For our class, the word included is going to mean between, directly between. So angle B here in red is between sides AB and side BC because it's connecting the two. Go ahead and copy these down into your notes. Okay, what you have here is two pairs of sides that already match. You have two S's, and here you have two pairs of sides that already match. But for the top one, we want to represent side, side, side. So we need to put in a third side there so that we can have three pairs of sides. But in the bottom one, we want it to say side, angle, side. So think about where we have to put an angle in order to satisfy the shortcut side, angle, side. Up on the top, what we're going to do is we're going to go ahead and make a third side congruent to the other third side, 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 side. If you ever see markings like this, then you automatically know that the triangles are congruent, all the parts are congruent, because you have a side, side, side shortcut. Three sides. Or, I'm sorry, three pairs of sides. But here, you don't want another side. You don't have three S's. You want an angle. But the trick is that the angle has to be included between the two sides, like a sandwich. Okay, so that angle has to be a particular one, or this one. So think about where that angle would go. It has to be side, then angle, then side. So the angle has to be marked right here in order to make side, angle, side work. And then this one has to be directly between the two sides where they meet. It can't just be anywhere. It has to be labeled as side, angle, side. Side, angle, side. The angle has to be directly between the two sides. So we're going to practice this as a two-column proof though, because you already know in your head what you're doing. I want you to get practice writing it down on paper. So here I have them already done. Let's look at what you have. First thing you have to do is look at what you know. Look at this diagram here. What do you know already? You know that this mark is congruent to this mark. And you know that this mark is congruent to this mark. So therefore, side AB is congruent to side CD. And at the same time, side AD is congruent to side BC. That's what we know. How do we know that? Because it's given. Both of those are given. Now, we don't have side, side, side yet. That's what they want us to use, side, side, side. But all I have is one side here that matches this side, and one side here that matches this other side over here with two dashes. So I have two pairs of sides. I need a third pair of sides. Well, sometimes it's hard to see where the third side is. So you got to remember the things that we've learned in the past. I'll make a green triangle right here, and I'll make a red triangle. And I want you to look for a side that's used in both the red triangle and the green triangle that we could call congruent. Can you see right there? Remember how anything is equal to itself? AC, whether it's red or whether it's green, AC is still equal to itself. We call that reflexive. We put an X on it, and we realize that that represents a side on each triangle. That is a side on the green triangle, and that's a side on the red triangle. So therefore, we have AC is equal to AC, any segment is equal to itself, and that is the reflexive property, if you remember that from the past. And then lastly, we look at our picture. We have three pairs of sides that match. So we can say triangle ABC is congruent to triangle CDA by the side, side, side postulate. Example 2. We're going to try SAS this time, still using the two-column method. The first thing you have to do is decide what do you know. And what I know are these two markings here. And I'm going to color them again so that we can keep track of them. I'll make the green triangle the top one. And the bottom triangle will be red. Well, I'm going to make it blue since the markings are already in red. And we have to look at the markings because we don't have any other given information here, just the diagram with the markings. So this represents a side right here that matches this side. This little mark here represents an angle that matches this angle right here. And now I look at what else I can see. I don't see anything else that's given to me, but I do have side AB is congruent to side BD, and I also have that angle ABC is congruent to angle CBD. Both of those are given from the markings. Now I have to look at what I can see from that. I'm trying to do side angle side, so I'm looking for another side, and I see it right here. This side is equal to this side. BC is equal to itself, whether it's the green BC or whether it's the blue BC, it's still the same thing. So the green side BC matches with the blue side BC, and that gives us side angle side. So we can write that down as BC is congruent to BC, and the reason is reflexive. Any segment is equal to itself. And then when you look back at the picture, you have side, angle, side. You have these two sides, and where they meet, there's an angle marked in between them that's congruent. And these two sides here, the angle in between them is marked congruent. So we can say side, angle, side in the green one, and we can say side, angle, side in the blue one. So the two triangles are congruent. ABC is congruent to triangle DBC by side, angle, side. That's it. You have to look at what you're given, what else you can see in the picture, and then from your markings, choose one of the shortcuts that could work. For this last example, we have to do a little bit more with it. We have to prove that some things are congruent, because all they told us is that x equals 3. So what we're going to do is take x equals 3, and we're going to use that first. So here, if x equals 3, this becomes 3 times 3, or 9, minus 5, and that, of course, equals 4. Well, 4 equals 4, so I can automatically put congruent markings there. X equals 3 right here, so I could plug this in and call this 3. This side of 3 is congruent to this side of 3. Why? By the definition of congruence. Two things that are equal are congruent. And the last one, if x equals 3, I plug it in right here, 3 minus 1, and I get 2. And that makes this side equal to the other side, that's 2, which is right over here. So now, you've got all your markings. You just have to write it down as a proof. What we know now is these three things. We know that UW is congruent to ZY because they were both equal to 2. We know that VW is congruent to ZX because they're both equal to 3. And we know that VU equals XY because they're both equal to 4. Why? Because the definition of congruence. We plugged it in, we substituted, we simplified, we got matching answers. So now look at what you're dealing with. This is a side. This is a side. This is a side that matches with this side. And this is a side that matches with this side. So therefore what you have are 3 pairs of matching sides. So you can say triangle UVW is congruent to triangle YXW by the reason of side, side, side.